Hi everyone, my name is Lara and today I'll be presenting my project on the evaluation of flavonoid detection, antioxidant activity, and antimicrobial potential of parsley before and after simulated digestion. Parsley contains bioactive compounds such as luteolin and quercetin, which are linked to antioxidant and antimicrobial properties. However, their detection and activity can vary depending on extraction methods, digestion, and analytical sensitivity. The goal of this study was to analyze flavonoid content using UPLC, evaluate the antioxidant activity using DPPH and FRAP assays, and assess antimicrobial activity against E. coli and Asorius while comparing crude and digested samples. Parsley leaves were dried for 48 hours, ground, and extracted using a 50-50 acetonitrile and water solution with 0.1% formic acid. The mixture was vortexed, sonicated, and centrifuged, and the supernatant was collected. For simulated digestion, parsley was homogenized in saline. A gastric phase was performed at pH 2 with pepsin, followed by an intestinal phase using pancreatin and bile at pH 6.5. Samples were incubated at 37 degrees Celsius and then centrifuged. Flavonoids were analyzed using UPLC at 370 nanometers. Antioxidant activities was measured using DPPH, which evaluates radical scavenging, and FRAP, which measures reducing power. Antimicrobial activity was tested using the well diffusion method against E. coli and Asorius, with ampicillin as positive control. All experiments were performed in triplicates and analyzed using one-way ANOVA. Luteolin and quercetin standards were successfully identified and separated at their retention time. However, no corresponding peaks were detected in parsley samples, suggesting that flavonoid concentrations were likely below the detection limit. The FRAP assay showed that the crude extract had higher reducing power compared to digested samples, with the 1:2 diluted crude extract showing the highest activity. In contrast, the DPPH assay showed higher radical scavenging activity in the digested samples, with the digested neat sample showing the highest activity. No antimicrobial activity was observed for parsley samples against either bacterial strain. However, ampicillin showed clear inhibition, confirming that the assay worked properly. Statistical analysis showed significant differences between groups. In conclusion, parsley showed antioxidant activity but no antimicrobial effects under the tested conditions. Flavonoids were not detected by UPLC, likely due to low concentration and detection limitations. Simulated digestion altered the antioxidant behavior, increasing radical scavenging activity while reducing ferric reducing power. Overall, these results highlight the importance of extraction, digestion, and analytical sensitivity when evaluating plant bioactivity. Future work should use more sensitive techniques such as UPLC, MS, include sample cleanup steps, and test more concentrated extracts to better evaluate antimicrobial activity. Thank you everyone for watching my presentation about my research project, and I hope you liked it.